Dear students, welcome. This is our 5th class on statistics. Today we shall try to solve these two problems. Very simple problem. Question number 21 and question number 22. Forces P and Q whose resultant is R. The resultant of the forces P and Q is R. Act at a point O. If any transversal cuts the lines of action of PQR at the points L, M, and respectively, then we have to show this one. See, suppose this is force P, this is force Q, this is force P, and this is force Q, acting at the point O. Acting at the point O. The resultant of P and Q is R. Suppose this is the resultant of P and Q, R. Next, we are given that any transversal cuts the lines of action of P, Q, R at the points L and M. Suppose this is the transversal. This transversal cuts the line P, Q, and R at the point L, M, and N. Transversal cuts the point at the points L, M, and N. Now we are drawing a suppose OX is a line. It is perpendicular to the transversal. Suppose I cap is the unit vector along the direction of OX. Along the direction of OX. Now let me write. Let us draw a perpendicular line. Let us draw a perpendicular line OX. Let us draw a line. Draw a line OX which is perpendicular to OX which is perpendicular to the transversal. Polar to the transversal. Perpendicular to the line transversals. Let I cap be the unit vector along the direction of OX. Be the unit vector. Be a unit vector along the direction of OX. Along the direction of OX. I cap is the unit vector along the direction of OX. Now, R is the resultant of P and Q. You may write R vector is equal to P plus Q. Now take the dot product with I cap. This means R vector dot I cap equal to P vector dot I cap plus Q vector dot J cap. Actually this which we have applied, you see, the sum of the resolved parts of two forces along any direction is equal to the resolved part of their resultant. This is the case. The resolved part of any force along a direction, this is equal to the dot product of the force and the unit vector along the direction. R vector dot I cap. Now you see. What is R vector dot I cap? R, magnitude of R vector R, magnitude of I1, and cos of angle between. You may write and cos of angle. Let me write like this. Cos of angle between R and I cap. What is cos of this angle? Cos of this angle. This is a right angle triangle. Cos of this angle equal to base by hypotenuse OX divided by OM. OX divided by OM. Cos of angle NOX, you may write NOX. NOX. This is equal to, similarly for this, magnitude of this vector into cos of LOX plus similarly cos of, it will be MOX. This means it is R, it is 1, and the cos of NOX based by hypotenuse, it will be OX divided by OM. OX by OM. This is equal to P into 1 LOX. OX by OL. OX by OL plus Q. Magnitude of the vector I is 1. Cos of MOX. It will be OX by OM. OX by OM. Now, OX by OM. This means R by OM, this is equal to OX will be cancelled from both sides, equal to P by OL plus Q by OM. Right? R by OM equal to P by OL plus Q by OL. Therefore, we have solved this one. Question number 1 has been solved. It is very easy. Now, I am going to solve the question number 2. Solve questions. This is the transversal. We draw perpendicular OX. We draw perpendicular OX, which is we draw a line OX which is perpendicular to the transversal. Then we can solve in this way. Now, try to solve the question number 2. Today's question number 2, and as a whole, the question number 22. What is this? Two unequal forces P and Q act at an angle alpha, so that their resultant is nearer to the greater force. Resultant is nearer to the greater force. Suppose two forces P and Q, P is greater than Q. Let us suppose that P is greater than Q. Suppose this is force P. Suppose this is force Q. They act at an angle alpha. Suppose their resultant is R. The resultant makes an angle theta with the direction of P. Now, let us. Yes. Well, yes, we can remove this one. Let the forces P and Q are acting. P and Q act at the point O. The angle between P and Q is alpha. Let alpha be the angle between the forces. Let alpha be the angle between the forces P and Q. Let alpha be the forces. Alpha be the angle between the forces P and Q. Let R be the resultant of P and Q. Let R be the resultant of P and Q. Resultant of P and Q. resultant of the process P and Q. Let the resultant R makes an angle theta with the direction of P. Let the resultant R makes an angle theta with the direction of makes an angle theta with the direction of P. What we are going to prove? We are going to prove that the resultant is nearer to the greater force. Suppose that P is greater than Q. Now, magnitude of the vector P and magnitude of the force Q is Q. Suppose this is one, magnitude of P is P, magnitude of Q is Q. Let us suppose that with the direction of P, we have tan theta equal to, from tan theta is equal to Q sine alpha divided by P plus Q cos alpha. This is the formula. It was derived earlier. It has already been derived earlier. Now, tan theta is equal to Q sine alpha divided by P plus Q cos alpha. Let us suppose that the force P is greater than Q. Let us suppose that. Suppose that P is greater than Q. Let us suppose that P is greater than Q. Now, you see, P is greater than Q. Now, tan theta equal to Q sine alpha divided by P plus Q cos alpha. This means tan theta equal to sine alpha, divide numerator and denominator by Q. You may write like this. Numerator and denominator by Q. You may write like this. Now, this means this. Suppose this is number 1. Now, P is greater than Q. P is greater than Q. This means P by Q is greater than 1. P by Q is greater than 1. This means P by Q plus cos alpha is greater than 1 plus cos alpha. Is greater than 1 plus cos alpha. This means take the reciprocal 1 by P by Q plus cos alpha. Then the sign will be changed. Greater than will be converted to less than. You will get this one. Multiply numerator and multiply both sides by sin alpha. Sin alpha divided by P by Q plus cos alpha is less than sin alpha divided by 1 plus cos alpha. 1 plus cos alpha. I am writing this. Now, sin alpha divided by this is tan theta by 1. This means tan theta is less than. Sin theta means you may write twice sin alpha by 2, cos alpha by 2. You may write twice cos square alpha by 2. This means from this tan theta is less than 2 will be cancelled. Cos alpha by 2, cos alpha by 2 will be cancelled. It will be tan alpha by 2. This means theta is less than alpha by 2. Theta is less than alpha by 2. Now, what is the angle between P and Q is alpha. What is alpha by 2? This is alpha by 2. This is alpha by 2. This angle is alpha by 2. It is the this, suppose this line bisects the lines this and this. Bisects the lines, lines exons of the process P and Q. If it is bisector, then you see from the diagram, theta must be, theta is less than alpha by 2. This means the resultant is nearer to the greater force, because we have already supposed that P is greater than Q. This means that is the resultant is nearer the greater force. Nearer the greater force. Dear students, perhaps you have understood these two problems. Very interesting and very simple problems. Today, I want to stop here. Thank you. Thanks for attending the class. Thank you very much.